This video will focus on radical expressions and rational expressions. If you haven't done so already, I'd like you to pause the video and attempt the warm-up. When you're ready to check your work, hit play. Number 1, you would use the product property for the properties of exponents, which says that when you multiply two things that have the same base, you can add the exponents, which gave me 7 to the 5th power, or that's 16,807. Number 2, we have the quotient property for our properties of exponents, which says when we divide having two things with the same base, we can subtract the exponents, which gave me 11 squared, or 121. Number 3, we have a power to a power, and when that happens, you can multiply the exponents, so 3 to the 6th power, or 729. Number 4, we have a radical that we could simplify. Remember, whenever you want to simplify radicals, you think about the perfect squares that are in its factors, and you want to use the biggest one. So 25 times 3 gives me the 75. 25 is the perfect square of 5, that's why I pulled that out. And then 3 remains, because that's not a perfect square. And no factors of 3 are perfect squares greater than 1. So that means that it is the most simplified. Number 5 was a bit more challenging. Here you had to rationalize the denominator. So you should have multiplied by the ratio root 7 over root 7. Using product property, I multiplied the numerators and denominators together. So I had 20 times 7, which gave me 140. And then root 7 times root 7 is the square root of 49, which is 7. You couldn't leave your answer as the square root of 140 over 7, though. You were supposed to simplify the radical, which I did over here. And you can see how I got my final answer of 2 root 35 all over 7. All we're going to do for this next section is talking about how to find real roots. So we're not going to be dealing with imaginary numbers for right now. I just want to see if there's any real solutions. But before I do that, it might help if I give you some terminology. Whenever we have a root, that's this right here. Okay? You've seen it before in the square root. We also, instead of calling this a root, could call it a radical expression. And in radicals or roots, we have something that's called an index. The index is which root we are using. And then what's inside is called the radicand, what we are taking the root of. For example, and I'm just going to put this in terms of what we've worked with thus far. If I have, like number 4, I had the square root of 75. The index of the square root is actually 2. We just don't usually write it. So if I say, what's the index of the square root, the index would be 2. And what is the radicand? Well, the radicand is what we're taking the square root of. So that would be 75. Whenever you're taking an odd root, so like 3, 5, 7, so on and so forth, we're going to have one real root or one real solution. For example, it says the real third root of 8 is 2. What that looks like is the cube root of 8 equals 2. 3 is the index, 8 is the radicand, and 2 is the solution. Because it was an odd index, I have one real solution of 2. When you have an even index, we're going to have 2 real roots or 2 real solutions. You've already seen this before. Remember how when I was dealing with solving quadratic equations and we were using square root property, I told you guys that whenever you take the square root, you must put plus or minus. So if I take the 4th root of 16 my solution will be plus or minus 2. An even index of a negative radicand. So this was a positive. Now I'm going to do a negative. What if it was the fourth root of negative 16? So before, when we were dealing with square roots, we would say, oh, it's just the fourth root of 16 times I. But I told you, we're not going to be using imaginary solutions. I'm only interested in real solutions. And there are no real solutions for a negative number when it's an even index. But when it's an odd index, like root 3 of negative 8, that's okay. That would actually be a negative 2. So once again, if you take an odd root of a negative radicand, it's okay. But if you take an even root of a negative radicand, you will have no real solutions. And last bit, if you have a radicand of 0, so for example, if you have the cube root of 0, the answer is just 0. For A through H, all we're going to do is write how many solutions it has by looking at what we're given. So for A, I have the fourth root of 81. The fourth root of 81. Well, this is an even root, so I know I'm going to look here, even root. And it is a positive radicand. So I know I'm going to have 2 real solutions. I just want to show you what that actually is going to look like. Because it's 2 real solutions, I know it's going to be plus or minus. And when I ask, what is the fourth root of 81? I'm asking you, what to the fourth power will give me 81? Okay? What to the fourth power will give me 81 is what I'm asking. So we're looking for perfect fourth powers. Before, we would look at perfect squares when simplifying the radicals. So it's a different process. If you wanted to try different things in your calculator, you could. So you could be like, okay, well, let's try 2 to the fourth power. That doesn't work. I got 16. Okay, what about 3 to the fourth power? 81. There you go. I'll also show you how to plug the fourth root into our calculator. So for the fourth root, I need to hit 4, and then second power, right here, that little caret looking thing. So that means it's the fourth root of, you plug in the number, 81, you see we get 3. Okay, next we have the cube root of negative 125. So yes, this is a negative radicand, but it's an odd index, so we will have 1 real solution. You basically have to ask yourself, what cubed would give me negative 125? Again, what cubed would give me negative 125? Well, negative 5 cubed would give me negative 125. Notice how I'm using exponents to answer the radical questions, and when we deal with radicals, we are technically using properties of exponents as well. That's because they're inverse operations. Okay, part C. 6th root of negative 729. I don't even have to go through the process of trying to figure it out because I want you to notice this is an even root and I have a negative radicand. It's okay when we have an odd index, but with an even one, no. There's going to be 0 real solutions. And part D, what is the 5th root of 0? Well, that's just going to give me 1 root of 0. So really, that's 1 real solution of 0, like I said. All right, why don't you pause the video and try E, F, G, and H. Hit play when you're ready to check your solutions. Part E, we had the 4th root of negative 256. That's an even root of a negative radicand, so there's no real solutions. F was the 6th root of 1. It's an even index and a positive radicand, so I knew there were 2 real solutions. It's 2 real solutions because of that plus or minus. And then you have to ask yourself, what to the 6th power will give me 1? So what to the 6th power will give me 1? Well, that's positive or negative 1. G, we have the cube root of 125. It's an it's an odd index of a positive radicand, which means we have 1 real solution. What cubed would give me 125? Well, that's 5. H, we have the 5th root of a negative number, but that's okay because it's an odd index of a negative number, so we will have 1 real solution. That solution is just going to be negative. And what to the 5th power will give me negative 32? Well, that's a negative 2.